Dear students, now I am starting new chapter probability. Now before starting topics in this chapter, let me explain some basics of probability which you should know. Basics from class 11. Say in class 11 you learn these properties, revising formulas of class 11. Then we are starting a topic from class 12. So in class 11 you learn about these topics. Let A be the event associated with sample space S. If A has R elements, S has n elements, there are n sample points, then probability of event A is R by n. So maximum this formula we are using to find probability of events. Then second property, probability of complementary event P of A dash, that is equal to 1 minus probability of A. Say probability of event S is sample space, so it is sure event, its probability is 1, and probability of impossible event is 0. This means sure event, certain event, this is impossible event. Then probability of A union B, probability of A union B, probability of union of two events, it is equal to probability of A plus probability of B minus probability of A intersection B. So probability of union of two events. Then probability of A intersection B dash, means probability that A occurs and B does not occur. A occurs and B does not occur. That means probability of A minus probability of A intersection B. Probability that A does not occur and B occurs, that is probability of B minus probability of A intersection B. Then if intersection of two events is empty, then A and B are said to be mutually exclusive events. These are the words, this is the terminology which we are using in this topic probability. If intersection of two events is empty, then both events are said to be mutually exclusive events. If their union, if union of two events is sample space S, then A and B, these events are said to be exhaustive events. And if satisfying both properties, if A intersection B is empty and A union B is S, then A and B are said to be mutually exclusive and exhaustive events. Then say here union of two events. When we say at least anyone from A or B occurs, if any one event occurs, this is denoted as A union B. That means A union B occurs. A union B occurs. Now symbols, meaning of words, at least, whenever you are given word at least, take union. If both A and B occurs, both A and B occur at a time, that means A intersection B occurs. Intersection of events occur. A occurs and B does not occur. This is denoted as A occurs and B does not occur, that means B dash occurs. So A intersection B dash occur. If A does not occur and only B occurs, that means A does not occur, means A dash occurs and B occurs. So this event occurs. Means exactly one event occurs. Only A occurs, then A intersection B dash. Only B occurs, A dash intersection B. Neither of the event occurs. Neither of the events from A and B occurs. That means A dash occurs and B dash occurs. So neither of the event occurs, that is A dash intersection B dash occurs. And sometimes we use De Morgan's rule to calculate probabilities. That means if you want to find P of A dash intersection B dash, P of A dash intersection B dash, that means we do this as P of A union B whole dash. So De Morgan's rule is used, and this is equal to 1 minus P of A union B. P of X dash is 1 minus P of X. So these are basics of a probability which we will use in this new topic, which is continued in 12th class. These are results from 11th class. So remember this terminology. Now first topic of 12th class is conditional probability. To understand this definition, what means conditional probability, what is its formula, and results related to conditional probability, I am taking one example. Suppose a tossing 3 fair coins. In experiment of tossing three fair coins, sample space associated with this experiment is, taking sample space as, when we toss 3 coins, elements are H, 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 T, H, T, H, T, H, H, T, 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 H, T, H, T, H, T, T. So there are 8 elements in this sample space. Now let me take A is the event that at least 2 head appears and B is the event that first coin shows tail. A is the event that at least 2 heads appears, so I am putting elements in event A. 2 heads appears, that means H, H, T, H, T, H, T, H, H. In these 3 elements there are 2 heads in each entry. Sorry, at least 2 heads, that means 2 or more than 2. So 2 heads or 3 heads, because I have taken at least 2 heads, so 2 or 3 heads, so here it is 3 heads, H, H, H. So these are entries related to this word, at least 2 heads. B is the event that first coin shows tail. So first coin shows tail, that is, in this entry first coin is showing the tail, then here first coin is showing tail, here first coin is T, first coin is showing tail, here first coin doesn't show tail. So follow the words which are given. First coin shows tail, that means observe only first place. Here it is tail, here it is tail, here it is tail. Don't check second and third coin. First coin shows tail, it's enough. Take that element. Here at least 2 heads, so 2 heads, here 2 heads, 2 heads and 3 heads, so at least 2 heads. Now I am finding A intersection B. A intersection B. See, common in both. Common in both is, this is common, T, H, H. T, H, H. This is common. So T, H, H. It is A intersection B. Now slowly I am coming on that word, conditional probability. Now see, I am putting sample point in F favorable to event E. Sample point in F favorable to event E. So here it is, sample point in B favorable to event A. See, sample point in B favorable to event A, that means common. That is common element. That is common element. It is common in both, that is THH. Now, probability of event A considering B as the sample space, it is equal to number of elements in B, because B we have taken as sample space. Number of elements in sample space we keep in denominator, and number of elements in A which are common in B. So number of elements which are in A and common in B, that is, it is only one element, THH. So that means number of elements, number of common elements, that is number of elements in intersection upon number of elements in B. Now dividing this by number of elements in sample space, that is number of elements in sample space, that is number of elements in S, number of elements in S. So this is probability of A intersection B, and this is probability of B. So here probability of event A considering B as a sample space, that means B has occurred. Here we have taken condition that event B has occurred. So first B occurs. If B occurs, what is probability of A? So that is, this is nothing but in second words, so we can say, therefore probability of event A, probability of event A given that B occurs, given that B has occurred, it is equal to P of A, probability of A intersection B upon probability of B, and this is denoted by symbol P of A by B. Take here vertical line, P of A by B, probability of A given that B has occurred. So this is conditional probability. So it is equal to P of A intersection B upon P of B. So in this example, number of common elements, that is 1, and number of elements in B, that is 4. So for this example, here value of a P of A by B is 1 by 4. So in this example, probability of A by B is 1 by 4. That is a probability that at least 2 head appears given that first coin shows tail. So putting this in detail, that is, say here P of A by B is 1 by 4. That means conditional probability that at least two head appears, at least two head appears, at least two head appears given that B has occurred. It is 1 by 4. So probability of A given that B has occurred, that is a P of A by B. So this is a definition of conditional probability. Now results and definition. If E and F are two events associated with the sample space of a random experiment, the conditional probability of the event E given that F has occurred, probability of E given that F has occurred, that is probability of E by F, that is given by P of E by F is P of E intersection F upon P of F. P of F, that means probability of F. In short, I am speaking P of. So just discuss this definition by one example of tossing three coins. Now properties. Let E be an event of a sample space S, then probability of S by E, it is always 1. See, probability of S by E, that is probability of S intersection E upon P of E, and S intersection E is E, so P of E by P of E, that is 1. If A and B are any two events of a sample space S and probability of F is non-zero, then probability of A union B by F is equal to probability of A by F plus probability of B by F minus probability of A intersection B by F. Say this is similar to just discussed results, basics of trigger, basics of probability, probability of P of probability of A union B, probability of A plus probability of B minus probability of A intersection B. Now what is difference? So here I have taken now condition. Condition is F. So here by F, then I keep here by F, by F, by F. So it is converted into this result. Then we had one more result, probability of complement of an event, complementary event. So 1 minus probability of A. This was in class 11. Now I insert condition by F, by F. So it is this condition. Or if you keep here by B, by B, it is same. Now question based on these formulas, application of this formula. Question is, given that E and F are events such that probability of E is 0.6, probability of B, F is 0.3, probability of their intersection is 0.2. Find P of or probability of E by F and probability of F by E. So here, first of all, probability of E by F. Probability of E by F, we use this formula, P of E intersection F upon P of F. Now probability of E intersection F is given, it is 0.2 upon probability of F is 0.3. So this is 2 by 3 or 0.666. Now P F by E, P of F by E. So replace E by F and F by E. So probability of F intersection E, it is same as E intersection F upon P of E, F by E. So here condition is E. So whatever is condition, we keep in denominator. So here condition is F. So keep F in denominator. And their intersection is in numerator. This is the way to remember this formula. Now probability of E intersection F is 0.2 upon probability of E, that is 0.6. So it is 1 by 3. So these two values are asked in this question. We can also calculate more. As for example, suppose we want probability of E dash oblique F, probability of E dash oblique F, probability of E dash by F, that is by this formula probability of E dash by F is 1 minus probability of E by F. Say here E dash, so keep here E, here F, so put here F. So P of E dash by F is 1 minus P of E by F. So 1 minus P of E by F, that already calculated, 2 by 3. So it is 1 by 3. Suppose we want probability of E dash by F dash. Now probability of E dash by F dash. So by this property, E dash by F dash is 1 minus P of E by F dash. So here in this result, this is complement A dash, this is A. So here this is E dash, so keep here E. And condition we keep as it is. This is B, so B. So in this formula, A is replaced by E and B, this B in both the places, B is replaced by F dash. So now this is equal to 1 minus. Now here again we use a definition. P of E by F dash is P of E intersection F dash upon P of F dash. See here in this calculation, here there is F dash. So I replace F by F dash, F dash. Now we know that P of E intersection F dash is P of E minus P of E intersection F. P of E intersection F dash, it is P of E minus P of E intersection F dash. Divide by P of F dash is 1 minus P of F. So here we are using the basic properties of class 11. That P of A intersection B dash is P of A minus P of A intersection B, and P of A dash is 1 minus P of A. These basic properties I explained in this video in the beginning before starting this chapter. So this is equal to 1 minus, now P of E is given 0.6 minus P of E intersection F is 0.2 upon 1 minus P of F is 0.3. So this is equal to 1 minus 0.6 minus 0.2 is 0.4 upon 0.7. So 1 minus 4 by 7. So this is 3 by 7. If 2 times probability of A is equal to probability of B is equal to 5 by 13, and probability of A by B is 2 by 5, then find P of A union B. Say here twice P of A is equal to P of B is equal to 5 by 13. That means P of A is 5 by 26. See, from this value, P of A is 5 by 26 and P of B is 5 by 13. And P of B is 5 by 13. Now, we take formula for P of A by B, because value of P of A by B is given. P of A by B is P of A intersection B upon, say here condition is B, so P of B. Substituting values, P of A by B is 2 by 5 equal to P of A intersection B upon P of B is 5 by 13. That means P of A intersection B is 2 by 5 into 5 by 13, 5 cancel, so 2 by 13. We are asked to find a probability of A union B. Now, probability of A union B, we know basic formula. P of A union B is P of A plus P of B minus P of A intersection B. P of A is 5 by 26 plus P of B is 5 by 13 minus this is 2 by 13. So this is LCM is 26, 5 plus 10 minus 4. So it is 15 by 4, 11 by 26. This is required probability. Now say in this question, a coin is tossed 3 times. Coin is tossed 3 times. So sample space associated with this experiment is, sample space S is, it is 3 times. So H H H H H T H T H T H H T T T T T H T H T H T T. So this is the sample space associated with experiment of tossing a coin 3 times. Now we discuss first case. So here E is the event that head on third toss. Head on third toss, that means, see here head is on third toss. Here head is on third toss. Head is on third toss. Head is on third toss. These are elements in which head is on third toss. So E contains H H H H T H T H H T T H. F is event that head on first 2 tosses. Head on first 2 tosses. So say, now look again. Every time we check property for every element of sample space. Head on first 2 toss. On first 2 toss, head, first 2 toss. Head on first 2 toss. So these are only the elements in which head is on first 2 toss. Don't worry about third toss. Only condition is head on first 2 toss. Third toss can be any outcome. Focus only on given condition. Now, intersection of this is equal to H H H. Now, probability of E by F is by formula P of E intersection F upon P of F. Now probability of intersection, that is 1 by 8. Here E intersection F has one element, sample space has 8 elements, so it is 1 by 8 upon probability of F, that is 2 by 8, so it is 2 by 8, so this is 1 by 2. Now second question, E is event that at most two tails, that is maximum two tails, at most, that is maximum two tails, that is two tails or one tail or zero tail, 1 2, 0 tail, 1 tail and 2 tail, that is at most 2 tail. So here say 0 tail, so here it is 0 tail, sorry, we have to take from sample space. Check here, we check this property for every outcome which is in S. So 0 tail, that is H. Here 1 tail, here 1 tail, number of tail is 1. 3 tail is not allowed, because what is given? At most 2 tail, maximum 2 tail, so this is not allowed. This is allowed, TTH. This is allowed, THT, HTT. So 2 tails, 1 tail and 0 tail. That is elements in event E. Now F, at least one tail. At least one tail means one or more than one tail. So 1 tail, 2 tail, 3 tail. Means 0 tail is not allowed. So accept this. Here 1 tail, HHT, HTH, THH, 3 tail allowed, 2 tail allowed. So this is at least one tail, means 1 or 2 or 3 tails. Now there are common is, say here, which is not a common element. Here HHH, it is in this set while it is not in this set. TTT, it is in this set while it is not in this set. So these are not common. Remaining are common, HHT, HTH, THH, TTH, THT, HTT are common. So common elements HHT, HTH, THH, TTH, THT, HTT. 6 elements are common. So probability of E by F is probability of E intersection F upon P of F. E intersection F, that is 1 2 3 4 5 6 elements, so 6 by 8, so it is 6 by 8 upon probability of F, 1 2 3 4 5 6 7 elements, 7 by 8, so 7 by 8, so value is 6 by 7. Say here, a die is thrown 3 times. E is event that 4 appears on the third toss. F is event that 6 and 5 appears respectively on first 2 tosses. Find probability of E by F. Say here, sample space associated with experiment of tossing a die 3 times. So sample space associated with experiment of tossing a die 3 times contain 6 into 6 into 6, that is 216 elements. Sample space contains 216 elements. Now E, we want probability that E by F. So see, probability that E by F. So by formula we require probability of E intersection F upon P of F. So first of all we think about E intersection F. So E intersection F means event satisfying both conditions, that 4 appears on the third toss and 6 and 5 appears respectively on first 2 tosses. So E intersection F, this set is set of elements satisfying both conditions. 4 appears on first 4 appears on third toss. So on third toss 4 appears and 6 and 5 respectively on first 2 tosses, 6 and 5. So there exists such one and only one element satisfying both conditions. No any other element exists other than this element. So E intersection F has only one element. Then F, what means F? So F is, we make list of elements in F. 6 and 5 on first 2 toss. So 6 and 5 on first 2 toss. That is the condition. First 2 toss 6 and 5. So third toss possibilities 6 5 1, 6 5 2, 6 5 3, 6 5 4, 6 5 5, 6 6 6. So this is event F, first 2 toss 6 and 5. No any condition for third toss. So take all possibilities for third toss. So now required probability is, probability of this is 1 upon 216 divided by probability of F is 6 upon 216. 6 upon 216. So required probability is 1 by 6. Now in this question, a black and a red dice are rolled. That means 2 dice are rolled. So sample space, say here suppose we denote symbol X. X denotes outcome on black die and Y denote outcome on second red die. So S is set of ordered pairs when 2 dice are rolled, black and red. So this is outcome on black die, this is outcome on red die. So here X and Y are taking values 1 to 6 up to 6. So S contains 36 elements. So S contains, therefore S contains 36 elements. So sample space has 36 elements. Now we suppose, now we are finding probability for case A. Find the conditional probability of obtaining a sum greater than 9. Let me suppose event E. E is the event that sum is greater than 9. Sum is greater than 9, and given that black die resulted in a 5, so F is event that black die shows 5. It shows 5. So we suppose these symbols. We want conditional probability of sum is greater than 9 given that black die resulted in 5. So this is a given that. This is a given. So if F occurs, given word is for F. So F has occurred, then what is the probability of E that is required? So here required probability is P of E by F. Given we keep below E, so by F, and we need a probability of E. So conditional probability of, so of, after of the words are sum is greater than 9, so probability of E, so put E on left of this vertical line, and given, that means event which has occurred, on the right side of this vertical line. So by definition, P of E intersection F upon P of F. Now let me find these values. E intersection F is required, and say E intersection F, that is elements satisfying both conditions. Sum is greater than 9. Black die shows 5. We can also show E and F individually without finding direct E intersection F. Here number of elements was more, so we found directly E intersection F. In this case, number of elements in case E, in event E, it was a greater number. So here we didn't find elements in E, direct we found E intersection F. But here there are no greater number of elements. So E is, sum is greater than 9, that means in the line of 1, 1, 1, 1, 2, 1, 3, 1, 6, maximum is 7, maximum sum is 7. Then check 2, 1, 2, 2, 2, 3, 2, 6, so sum is 8. Now take line of 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 6, sum is 9. But we want greater than 9, so don't take 3, 6. Take 4, 4, 5, sum is 9, but we want greater than 9, so take 4, 6. Then 5, 5, don't take 5, 4. We don't want equal to 9, we want more than 9, so 5, 5, 5, 6. Then 6, 4, 6, 5, 6, 6. F is black die shows 5. Black die, that is first die. X denotes black die. So black die shows 5. That means this is first outcome is from black. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. So these are possibilities in which black die shows 5. Now common is 5, 5, 5, 6 are common. 5, 5, 5, 6. These two are only common elements. So probability of E by F is probability of E intersection F, that is 2 by probability of intersection F is 2 by, here sample space has how many elements? 36. So 2 by 36 upon probability of F. F has 1, 2, 3, 4, 5, 6 elements. So 6 by 36. So this is 1 by 3. Now see, solution for B. Find conditional probability of obtaining sum 8 given that red die result in a number less than 4. Find the conditional probability of obtaining the sum 8. We are asked probability of sum 8. So let me suppose E be the event that sum is 8 and F be the event. F we take for given that red die result in a number less than 4. So it is event that the red die resulted in a number less than 4. Red die, that is second die. We want probability of, here probability of E by F. Formula is P of E intersection F upon P of F. Here given word is for this event, given that, so it will be on the right hand side of this vertical line, and we want the probability of this event under this condition. So let me find event E. E contains sum is 8. Sum is 8, that is, see, obtaining sum 8. So sum 8 is in the second line. 2, 6 has sum 8. Output 2, 6, then 3, 5, then 4, 4, 5, 3, 6, 2. So here sum is 8. This is event A. Now F is second red die results a number less than 4. Less than 4 means second output is 1, 2, 3. Second place output is less than 4. So 1, 2, 3, that is second output. First die is black, second die is red. So see, if we take 1, 1, so here 1 is allowed. 1, 2, here second output is 2. 1, 3, second output is 3, allowed. But 1, 4 is not allowed because red die has number less than 4. Similarly, 2, 1, 2, 2, 2, 3. Focus only on these words. Red die has output less than 4, whatever is output from black die. Focus on red die, that is focus on second element only. 1, 2, 3, 1, 2, 3, then 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, 4, 3, 5, 1, 5, 2, 5, 3, 6, 1, 6, 2, 6, 3. On black die result can be any number. Words are for red die only. Red die results in number less than 4. Now intersection. Intersection of these two is say here, this is 6, it doesn't belong to this set. 5 does not belong to this set. 4 does not belong to this set. This is the set of all ordered pairs in which second element is 1 or 2 or 3, not 4, not 5, not 6. Here 3 and 2, these are allowed in this set. So 5 3 comma 5 2. So now required probability is probability of intersection, that is 2 by 36. 2 by 36 upon F contains 1 2 3 4 5 6 into 3 18 elements. 18 by 36, so this is 1 by 9. Assume that each born child is equally likely to be a boy or a girl. If a family has 2 children, what is the conditional probability that both are girls, given that the youngest is a girl, at least one is a girl? So there are 2 sub questions in this question. See, family has 2 children. So first of all we put sample space. Sample space associated with a family having 2 children is sample space S is equal to, see, 2 children, so these are possibilities. First is boy, second is boy. First is boy, second is girl. First is girl, second is boy. First is girl, second is also girl. So it is like if a coin is tossed 2 times, story is different. That was story of tossing a coin 2 times. So only 2 possible outcomes every time on every toss, H or T. Here boy or girl. Now we want conditional probability of this event. Both are girls. So let me suppose, let E be, or we take A be the event that both are girls. Both are girls. So event A has a element both are girls. So first is girl, second is girl. So G. So both are girls. So only one element, only one sample point in S. Then we suppose event E1 for youngest is a girl. Event E1, youngest is a girl. That is, youngest means second child, that is youngest. First child is not youngest, second is youngest. So youngest is a girl. So here this is youngest, girl. Here youngest is a girl. We are given words youngest is a girl. We are not given anything, any condition regarding which one is first. So second is a girl. So second is a girl. First can be anyone, either boy or girl, but second is a girl. That is BG, comma GG. Second is a girl. Youngest is the girl. Then we suppose this for E2, event E2. E2 is at least one is a girl. At least one is a girl. Means one girl or two girl. means zero girl not allowed. That means except BB. So E2 contains BG, GB, GG. Now we calculate required probability. First is conditional probability that both are girls, given that the youngest is a girl is P of conditional probability that both are girls, that means probability of this event, given that, that is after vertical line put symbol for that event, given that youngest is a girl, so E1, that is probability of A intersection E1 upon P of E1. Now say here A intersection E1, it is equal to, this is A, this is E1, so it is GG. We will also require A intersection E2. A intersection E2 is again GG, that is A intersection E2. So P of A intersection E1, so this intersection contains only one element, so 1 by 4, so 1 by 4 upon E1 has two elements, so 2 by 4, 2 by 4, that is 1 by 2. Then conditional probability that both are girls, given that at least one is a girl, that is A by at least one is a girl, that means E2, A by E2. So by formula P of A intersection E2 upon P of E2. A intersection E2 has only one element, so this is 1 by 4 upon E2 has 3 elements, so 3 by 4, so that is 1 by 3, that is required conditional probability. Say here given that an instructor has a question bank consisting of 300 easy true false questions, 200 difficult true false questions, 500 easy multiple choice questions, and 400 difficult multiple choice questions. If a question is selected, one question is selected at random from the question bank, what is the probability that it will be an easy question? So we are asked a probability of easy question, given that it is a MCQ. So this is condition. So for these words we take E, symbol E for event, and for these words given that we take F. So here total number of questions equal to, question bank contains 300 plus 200 plus 500 plus 400, that is 1400. total questions. So sample space contains 1400 sample points or elements. So this is value of n is 1400. Now we suppose let E be the event, that an easy question is selected, an easy question is selected, and F is the event that it is a multiple choice question, a multiple choice question is selected. So E intersection F, that means what? Easy and MCQ. That means easy MCQ is selected, and easy MCQ is selected. Now see, here required probability is probability of easy question, that means probability of E, given that easy MCQ, it is MCQ, so F, that is P of E intersection F upon P of F. Now see, here E intersection F contains how many elements? Easy MCQ. How many are easy MCQ? Easy multiple choice question, that is 500. So E intersection F contains 500 elements. So probability of E intersection F is 500 upon 1400 divided by, now F contains, F is MCQ, MCQ is selected. So how many total MCQ? Easy plus difficult, total 900, 500 plus 400, that is 900 MCQ. Total MCQ 5 plus 4, that is 900, because in F only word MCQ is given. So probability of F is 900 divided by 1400. So 900 divided by 1400. So required probability is, it is 5 by 9. So this is required probability. Consider the experiment of throwing a die. If a multiple of 3 comes up, throw the die again, and if any other number comes, toss a coin. Find the conditional probability of the event the coin shows a tail, given that at least one die shows a 3. Say here sample space. First of all, we keep sample space. Sample space associated with this experiment contains, now we keep list of elements or sample points. A die is thrown. Now when throwing a die, if multiple of 3 comes up, suppose when we toss a die, which are multiples of 3? Only 2 numbers, 3 and 6. So suppose first 3 comes up, then what happens? If 3 comes up, multiple of 3 comes, throw die again. So second time throw a die. So second time 1 can come up, or second time 2 can come up, or 3 can come on second time. Second time any output can come up. But second time we toss a die if first time 3 comes up. Now if first time 6 comes up, then also second time we toss a die. So second time any number can come up. Then if any other number comes, toss a coin. Suppose 1 comes, when tossing a die 1 comes, 1 is not multiple of 3. So if the number is output is not multiple of 3, toss a coin. So second time toss a coin, so that is 1t, or with 1 h can come. Then if 2 appears on die which is not multiple of 3, so toss a coin, so 2h, 2t. If 3 comes, then done. If 4 comes, so 4h, 4t. 4 is not multiple of 3. Similarly 5 is not multiple of 3. 6 is a multiple of 3. For that, done. So these are elements in this sample space. So S has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So S has 20 sample points or 20 elements. Now we take events. Let E be the event that the coin shows a tail. The coin shows a tail. So E is coin shows a tail. That means here coin shows a tail. 1t, then 2p, 4t, 5t. Given that is for condition, given that, let me say F is event that at least one die shows a 3, at least one die shows a 3, that means F contains elements at least 1 3. At least 1 3 means 1 or more than 1 times 3. So 3 1. So we will take this full line of 3 1, 3 2, 3 3, 3 4, 3 5, 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. Then here also it is 3, 6 3. Then here it is, here nowhere t 3, so only this was with a 3. So 6 3, it was last entry, 6 3. So this is event F. Now required probability is P of E by F. Given that this is given, so put after vertical line P of E intersection F upon P of F. Now E intersection F, common in E and F, nothing is common, so E intersection F is empty. And probability of null set, that is probability of this impossible event is 0. So putting here 0 upon anything, this is 0. Probability of f can be counted, it can be calculated. It is 1 2 3 4 5 6 7. Probability of f is 7 upon 20. This value can be taken here, 7 upon 20, but final value is 0.